Hey guys, welcome back. So on yesterday's homework, most of you had a question about finalizing the answer on number 117 and number 119. So I will be doing a separate video going over those two, and I'll post that to Canvas, and it'll be in the modules under today, okay? All right, so today we're going to move on a little bit more practice and a little bit more difficult chain rule problems, okay? But before we do, okay, remember that these are the trig derivatives that you're supposed to know, okay? Honestly, as I've said before, these two, I don't really actually memorize, but the rest, yeah, you kind of will. And these are the most important. Those you need to know cold. I don't think this one's too difficult to remember either. Okay, so here we go. All right, I kind of already hinted at these problems yesterday, but now we're going to formally do these. This is still a chain rule because the outside function is the sine and the inside function is 5x. So the derivative requires a chain rule. So the derivative would be, and these are just real quick and easy. Ready? Derivative of the outside would be derivative of sine, which is cosine. Leave the inside the same, and then don't forget, times derivative of the inside, 5. Call it a day, you're done. Okay, here's the next one. Okay, so here's the next one. Derivative of the outside would be the derivative of this. When you write sine, change the sign. So that's negative 3 sine of, leave the inside the same, times derivative of the inside, which is 2. And if it's just one term, I put it out front because then I'm going to multiply these guys together. And my final answer would be negative 6 sine of 2x. Okay, quick and easy. All right, maybe you should pause and try the next one on your own. Okay, how'd it go? Derivative of the outside would be, when you write sine, change the sign. So that would be positive sine of 4x. Times the derivative of 4x, which is 4. Okay? Easy, simple. All right, the next one is actually not as easy, but not too awful yet, because it can get a little worse than this. The trick to this is don't write that cube where they always write it. That will mess you up. So take this 3 and make sure that you understand this actually means the same as 2, and then parentheses, sine of x, quantity cubed. If you see it like this, now it's an easy chain rule. But when you leave it like this, it's a little bit confusing. All right, so now give it a try. Pause if you want to try it on your own. Remember, derivative of the outside, leave the inside the same, then times the derivative of the outside. Sorry, derivative of the inside. Now I maybe messed you up. Maybe try again. Pause, try it on your own. Okay, my turn. Here we go. Ready? The derivative will be derivative of the outside, 6. Leave the inside the same, subtract 1. That's just the power rule. The power rule was the derivative of the outside. Left the inside the same, times the derivative of the inside, which is cosine. And that's your answer. You're good. Except they won't write the 2 here. They'll put it back here. So it'll be 6 sine squared x cosine x. Hope you're hanging in there. Okay, now we're going to change gears. There are a couple of other derivative rules that I have been holding out on you. Hold them back, and now we're going to do them. Okay? Okay, apparently I lied again. This is not a new rule yet. It'll probably be the next screen. Okay, so derivative of e to the x, you know the derivative of e to the x is e to the x. So this one's really easy, okay? The derivative of e to the x is e to the x, okay? But when it's not just e to the x and it's e to anything else, then the outside function is e, the inside function is the exponent. So this derivative would be, the derivative of the outside is the derivative of e to the 3x. So it's e to the 3x times the derivative of 3x, which is 3. Okay? So you could change this rule. It's probably written in the front cover of your book. The derivative of e to the u is e to the u times the derivative of u, which is du. E to the u du. That's what that du means if you see that in the front cover of your book. Let's do a couple of other quick ones. If I said f of x equaled -5 e to the 7x plus 1, then the derivative would be -5 e to the 7x plus 1 times the derivative of 7x plus 1, so times 7, which would turn that into a 35. Okay? A couple more. Okay, if you'd like, if you understood those examples, then hit pause and try this one on your own. Okay, the derivative of 5e to the junk is 5e to the junk times the derivative of the junk times -2, which makes it -10 e to the -2x plus 3. Okay, here's the new one. So the derivative of the natural log, okay? The derivative of, this is the new rule, the derivative of the natural log of u is 1 over u times the derivative of u. So if you have a natural log, the derivative of the natural log of something is 1 over whatever's sitting here times the derivative of that thing. So the derivative of the natural log of x is 1 over x times the derivative of x, but that would be a 1. So that'd be the answer. You're done. The derivative of the natural log of 3x would be 1 over 3x times the derivative of 3x, which is 3. And then that can simplify. The 3's would cancel and you'd get 1 over x. Okay, so the natural log. Let's try a few. Okay, so here we go again. The derivative of this would be, the derivative of the outside is the natural log. And that's 1 over whatever this junk is times the derivative of that. So the derivative of that would be 5. And that's it. You can't simplify this one because of that plus sign in the middle. Okay, try another one. Okay, how about this one? The coefficient in front is just brought down. So the derivative would be, you bring down the 3. The derivative of natural log is 1 over whatever this is. So it's going to be 1 over 2x plus 1 times the derivative of 2x plus 1, which is 2. And that 2 could go out here, but you'd end up just multiplying it by the 3. So I just put it up on the top. Okay, so my final answer would be 6 over 2x plus 1. Okay, let me give you one more like that. You try it on your own. Okay, you try this one. Hit pause and give it a shot. All right, let's see how you did. The derivative would be derivative of the outside, bring down your -5. Derivative of natural log is 1 over this stuff times the derivative of this stuff, which is 6x. And then just clean it up. -30x over 3x squared plus 1. How'd you do? Hopefully you're hanging in there. Okay, this next one is a trick. So I'm giving you a heads up. This is a trick, but you may not remember this from algebra. So let's see if you can recognize this trick. Okay, think about it. Look at that. Okay, the reason this is a trick is e is not a variable. E is a number. Okay, e is a number. So this is really the natural log. Whoops. This is really the natural log of like approximately 3 to the 5th. Well, the natural log of 3 to the 5th, there's no variable there. That equals some number. In other words, this is the same as saying f of x equals any number. Pick a number, who cares? This is really the equivalent of a simple number. Therefore, the derivative would be, what's the derivative of a constant? 0. That's a trick, okay? E is not a variable. E is a number. Here's another way to look at that same problem. If you remember from algebra, the natural log and the e undo each other. So this problem is really saying it's a natural log of e to the fifth, the natural log and the e undo each other. And this is really just a big fat 5. So it's literally f of x equals 5 is the actual value. Now do the derivative, and again, it's the derivative of a constant, so it is 0. Okay? Okay, this last one is really the meat of it, okay? This is where it gets tricky. This one, as you can see, hopefully it looks like a quotient rule, okay? It is a quotient rule, but remember when you do a quotient rule, you end up doing the derivative of both the top and the bottom. Well, when you do the derivative of the bottom, when we go to do the derivative of that is going to require a chain rule. And while that may seem crazy to you guys, doing a quotient rule and a chain rule at the same time is very, very, very common, okay? So when it's tricky like this and you have more than one thing going on at a time, I suggest you find the two derivatives of the two pieces, top and bottom, separately before you begin. So off to the side of my paper, I'm going to first figure out what is the derivative of this guy. Okay, so I'm going to rewrite that as x squared minus 5 to the 1/2 power. When I get to the part where I need the derivative of that, I'm going to have that answer. Okay, so let's figure out the derivative of this. And that you did that yesterday. That's just a power rule chain rule. So it's going to be 1/2, leave the inside the same, subtract 1, and you get negative 1/2, times the derivative of the inside, which is 2x. We still need to clean that up. On the top of this fraction, remember we can write this as one big fraction. The 2x will go on the top. On the bottom would go this 2, and move this guy back to the bottom, and maybe even consider rewriting it as a square root. Okay? And then since this is all connected with multiplication, these 2's cancel. So right now you have x over the square root of x squared minus 5 whenever we get to the derivative of this. Okay? And remember I said when you start with the square root, you end with a square root as well. Okay, so now we got to save all of that. Okay, and now we're going to do our quotient rule. Okay, so now we need to do the quotient rule. So here's my derivative. Low, square root of x squared minus 5, d high, derivative of that is a 1, minus high, d low. Derivative of this is what we found over here. Okay, so times x over the square root of x squared minus 5. Okay, draw the line and square below. Well, when I square the square root, square and square root undo each other. We just get this. Okay, so low d high d low, draw the line and square below. All right, now remember this is always two terms in the numerator. This is one term, this is a separate term. I want to squish this together as one fraction. And you really could have done that at the same time when you were writing this because I should have known x times x is going to be an x squared. So let me rewrite that a little bit neater. Square root of x squared minus 5 is one term. The second term is just an x squared on the top and a square root of x squared minus 5 on the bottom, all over x squared minus 5. All right, now, here's the issue we've had before. Algebra. We cannot leave fractions within fractions. Plus, I see this x squared minus 5 everywhere. So, how do we fix it? Okay, so how do we fix this? Anytime you have a fraction within a fraction, find the troublemaker, which is this guy right here, and just multiply by that. I need that to go away. So I'm going to multiply by a square root of x squared minus 5 for all of these terms. Square root of x squared minus 5 and a square root of x squared minus 5. And it actually ends up being pretty easy. In the first term, a square root times a square root, you basically squared a squared root, so you get just what's underneath. In the next one, the square roots cancel. That was the whole point of what we just did. And on the bottom, can you see that it's the same stuff written twice? Well, that's the same as if I had x times x to the 1/2 power. It's no different than x cubed times x squared. what do you do to your exponents when you are multiplying? You add them. So this is going to be x squared minus 5 to the, you have an exponent of 1 and you have an exponent of a 1/2 because the square root is 1/2. Add those up. 1 plus a half is 3/2. Okay? Combine like terms in the numerator and you're done. And look at that. The x squareds go away. So we have final answer, -5 over x squared minus 5 to the 3/2 power. And you could rewrite that as a square root and then cubed also. All right, that's as bad as it gets. If you need to, rewind back through that, okay? Good luck with your homework and keep inboxing me or messaging me and telling me when you need me to work out some problems for you, okay? Good luck, everybody. And I need to post the even answers. I don't think you guys have those yet. Bye.